Now, as you can see, as soon as I turn the overhead on, it has to do with the control, movement, and storage of radioactive material. There are, as you'll find out, many regulations that do govern the handling of radioactive material. There's a licensing process, the whole 9 yards, and once you're licensed to do it, then, or to handle it, possess it, and use it, then there are specific regulatory requirements that apply to you that you need to be familiar with. When I say you, I mean the licensee. And as an employee of the licensee, especially as radiation protection technicians, that's your job function. That's what you're going to be facing, ensuring compliance with, and fulfilling the procedural requirements to ensure that that compliance is met. As far as our outcomes, there really aren't that many as far as number, but I'll caution you, they can be deceiving. There's a lot of material. Identify NRC licensed radioactive materials that require special controls and discuss the controls that are required. We're going to go in and look at the regulations. What you'll find out, and we've mentioned this before, is you get to your facility, there will be procedures galore that implement these regulations. And while we can't cover every circumstance, what we can do is take you back to the regulation and talk about what that requires. And then, as you'll find out, you get to your facility, you'll have different procedures to adhere to. We're going to look at the packaging, marking, and labeling requirements for radioactive sources. And this learning outcome is a little misleading in that we're going to look at really the packaging, marking, and labeling requirements for all radioactive material by regulations. We will differentiate those that are required for the sources, because there are some specific ones. 10 CFR 835 does a really good job coming in and really identifying and putting together their requirements for radioactive source material. And they are above what you'll find in 10 CFR 20. A little bit more detail. And then we're also going to look and see what the regs require as far as posting. Posting radioactive materials areas and also storage areas. And then finally, we're going to talk a little bit about some of the special restrictions and requirements for outdoor storage. And there are some that we need to talk about to make sure that you understand. So with that, we're just going to lay it out, basically a little introduction to what we'll try to get done tonight. Maybe into 10 CFR 19, maybe not. And then we're going to spend most of the time looking at 10 CFR 20 and 10 CFR 835, specifically as it pertains to radioactive material regulations. And of course, questions are always appropriate. In way of the introduction, we've already talked. There's a lot of regulations that do govern radioactive material and its use. A lot of it's geared toward dose and minimizing dose and the lower dose, but it all stems back to what is the source of it all. This is the radioactive material that you possess and use as part of your license. But there are three specific ones we're going to take a look at. 10 CFR 19, which is entitled Instructions to Workers, that's the abbreviated title. It has a fuller title. 10 CFR 20, Standards for Protection Against Radiation, and then 10 CFR 835. Those are our three big ones we're going to look at. Now, we'll introduce other regulations or portions of other regulations as it's appropriate, but our focus is going to be on these three. Now, I debated on how to structure this. We could just go through and say, well, let's see what 10 CFR 20 says about this, 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 and this. And then let's go back and look and see how 10 CFR 835 says about this, 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 and this. I decided to change that a little bit and talk about this and then see what the regs say about that. And then the next topic, such as, we're going to look at some general definitions that you need to understand, know what they are, so that you can understand when the regulation uses it, what it means. Then we're going to get into the types of radioactive material that are defined in the regulations. And there are some very specific ones the language and the terminology is important because it determines which part of the regs you go to. There are also survey monitoring requirements, very general in nature actually, for the most part. There are some specific ones. But if you'll recall when we talked about introduction to regulations, we said that they're written really in a general principle sense and not so prescriptive that every time you change technology, you've got to change the regs. You'll see some of that as far as the survey and monitoring requirements. Real good illustration of that. Then there are some storage and control requirements specific to radioactive material that are specified in the regulations, 10 CFR 20 and 835. Again, not as specific as what you might think, but there are some specific ones we'll talk about. Then we'll cover the area posting requirements. This is probably going to be duplicated in your RPT 243, so what you're seeing here may be reviewed for you by the time we get to it. But we will cover it but we'll just cover the radioactive material portion of it because that's what we're concerned with. And then package labeling requirements, and labeling should have only two elements. And then the receipt and opening of radioactive material packages. This is very specific in both regulations, and you'll find there's a lot of common ground between 10 CFR 20 and 835. But it's very prescriptive of when you have to do these surveys for receipt and handle radioactive material. And then a very small topic, required reports. There are some very specific reports that we'll talk about. 10 CFR 20 is a little bit more prescriptive than 10 CFR 835. That's what you'll find out. So there's not a whole lot in 835. There are reporting criteria and reports that are required or contained in another regulation or a guide, but not so much in regulation. They have reporting requirements. Is that right, Jerry? You got a lot of paperwork and reports and stuff? Way too much? Somebody does, right? Okay, so that's how we're going to approach it. Those are the topics. That's the order we're going to take it in. And the first one I'll talk about is 10 CFR 19. This is that's the official title: Notices, Instructions, and Reports to Workers. In general, it really does. You can think of it in terms of a bill of rights for the rad worker. Because it really does, and it pertains to a qualified rad worker. This does not apply to a non-radioactive worker, non-rad worker employed at a facility. It's somebody that's going to receive this occupational dose in excess of 100 milligrams in the course of their employment, requiring them to be in or around areas that have radioactive material in them. Here are some requirements that the licensee must ensure that the worker is that he's informed of the storage, transfer, and use of radioactive material. That can be accomplished in a lot of different ways. Mainly it's accomplished through you and what you do as far as your job. Because you're required to monitor it, you're required to document surveys, you're required to install posting when it's appropriate, meets the right requirements. And so that is one of the ways in which this worker is informed. That's in all communication. And that satisfies, what you do satisfies the requirements of this regulation for notifying or informing the workers of the storage, transfer, and use of radioactive material. Transfer typically would be covered by, say, an escort. You'd be required to escort radioactive material through areas where workers would be, ensuring that it's done properly at certain levels. You have to be there for that. The licensee also has to ensure that the worker is instructed in the radiation protection problems associated with exposure to radioactive material. This is normally taken care of by the annual general employee training or general employee rad worker training that every facility has put together for people who work there. When you do your internship, you will undergo some level of training, depending on the facility that you're at, that satisfies the requirements of this. For those of you that are badged, Jerry, anybody else working out the site right now? Susan? They all have to, are you a qualified ground worker? You don't have a TLD?
We don't have anything.
Okay, y'all don't have anything over yet, right? It's all make-believe. Y'all have stuff though. Yes, sir. Y'all have radioactive material. You play with sources. Okay, so they have to have rad worker training annually, and it enables them and instructs them, satisfies this part of 10 CFR 19. Also satisfied by that rad worker training is that they'll be instructed in and required to observe regulations for protection of personnel from exposure. All of that is accomplished in the rad worker training. But it is a requirement and it's a responsibility of the licensee to ensure that that happens. Some other things also instructed in responsibility to report any condition, and this is very important. Although it's the licensee's requirement to ensure that the rad worker is instructed, it's the rad worker's responsibility to report any condition which might lead to a violation of regulations or lead to unnecessary exposure to radioactive material. So if you observe something that's not right as a rad worker working in a facility, and you're a qualified rad worker, if you observe something incorrect, either posting or labeling or the use of radioactive material, it is your obligation and duty under this regulation to report it to the licensee. I recall one time, I think, well, I've seen this particular part of the regulations used to point out people overlooking deficiencies in posting, for example, on an inspection, and the inspector comes in and should have been some posting up here and there's not, and everybody knows that it should be there, and everybody, I mean, it's in a high traffic area, people walking by it all the time, and no one ever reported it. And while they couldn't put it on one person, what they could show is basically a culture of insensitivity and really not caring a whole lot about what goes on in the facility. And they have cited that as the regulation that was violated. People did not report obvious violations. The licensee must also ensure that they are instructed in the proper response to warnings, alarms, flashing lights, things of that nature. Every rad worker must be instructed in the proper response to these activities, all associated with radioactive material. That basically is 10 CFR 19. We're not going, and if you look at it, it's not really that much more involved. You will see when you pull it up that there's a map that shows the different NRC regions. There's contact numbers for each of the regions, and really that's what it boils down to. Not really a big regulation at all. Any questions on 10 CFR 19? As it pertains to regulations regarding the control of radioactive material. Let's move on and get started on general definitions for 10 CFR 20 and 10 CFR 835. Now, as I said, all of these, there's a whole lot more definitions in 10 CFR 20 and 835 than what we're going to talk about. These are the ones that you need to understand the meaning of in order to understand some of the other regulations. 10 CFR 20, we'll do that one first. Control area, very important. It's an area that's outside of the restricted area, and I've got a little diagram that'll put all these types of areas together so you can kind of get a feel for it. But it's inside the site boundary, but it's outside of the restricted area. And the licensee can, if they so choose, restrict or limit access for any reason It may be because of radioactive material, it may be for other reasons. But that's a control area. Outside of the restricted area, but inside of the site boundary, access may or may not be controlled. An entrance or access point, any location which an individual can gain access to radiation areas or radioactive materials. This includes entry or exit portals of sufficient size to permit human entry, irrespective of their intended use. Now let me explain what that means. Y'all, you're familiar with room 509 down there, right? Back there in the mock-up area, we've got the cage that sometimes is a locked tie rat area, has a lock on it. That would not be acceptable because a person can climb over the top of it. That would be considered an access point. Permit human entry irrespective of the intended use. That would not be acceptable for an area that had, well, it would depend on how they wanted to define it. But basically, like for a locked tie rat area, that would not be acceptable. Because a human being could crawl over top of it. Isn't that crazy? Ooh. Yeah. Well, who would do it? They do it. Believe it or not, they do. So, the entrance or access point, normally you would think a door, right? That would be a whole lot simpler if it would just be the door. But because of problems that in the past, people have gained access to areas through areas that were not intended to be used as access points. And so they're in what? That's why this is defined that way. License. License means a license that has been issued under any of these parts. Okay, these are all, if you go and pull those up and look at them, you'll see that they're by category of material. Radioactive is one of them, medical use is another one. 50 is the one, 10 CFR 50 is the one for licensing domestic facilities for power production. 61 is the one for licensing burial sites. So any one of those issues a license. And so when it says license, it means any one of them. So if you're reading in the regs, 10 CFR 20, and you read the word license, it can apply to any license that's issued through the NRC. Now here's a key definition. Licensed material. It means source material, special nuclear material, or byproduct material that is received, processed, used, transferred, or disposed of under a general or specific license issued by the Commission. Within this, and you'll find we'll come back to it later, but within this, you'll find the three major types of radioactive material. It's all licensed material, but source material is one category, special nuclear material is another category, and byproduct material is the third category. All the radioactive material that you deal with will be one of those three types. Most of it will be this byproduct material. Most of it, not all of it. So it's a very key definition, understanding that it encompasses all radioactive material. Lost or missing licensed material. Pretty straightforward. Any licensed material whose location is unknown. It's licensed material, right? You've got a license for it, but you don't know where it is. It can include material that's been shipped but not received yet. You know, someone's shipping you some radioactive material and you haven't gotten it yet, or vice versa, and that you cannot find it within the transportation system. Now that's an important differentiation that it makes, because there's some thought sometimes that, well, it's under DOT reg, so if I put it into the transportation system under a DOT reg, then it falls outside of my regulations, my 10 CFR 20 requirements, and that's not true. So even if it's under the DOT regs being transported, if you don't know where it is within that transportation system, then it can be considered lost or missing. Restricted area is the next general definition. We used that earlier in the definition of control area. When we say controlled area is outside of the restricted area. A restricted area is any area access to which is limited by the licensee for protecting individuals against exposure to radiation or radioactive material. This, in most power facilities, will be the power block, which is turbine building, auxiliary building, reactor buildings, and adjacent or peripheral structures that have radioactive material stored in them. And it's interesting to note that it does not include areas that are used as quarters, residential quarters. Although you can set aside separate areas in residential quarters. The reason this is important here is in some plants, when they are under some limiting conditions of operation due to weather, such as hurricanes, and to go to quarter people on site, so that they have enough people on site in case, the roads get blocked and stuff like that. Then you start, there's usually a separate definition for that type of restricted area that will exclude a portion. So if you set up quarters to house those people, then you've got to take this into account. How have you defined your restricted area? And it may be that there are emergency specific emergency action levels that definition, that emergency action level definition shits in. But it's something to understand. That was talked about at the conference. Which plant was it that, David, do you remember?
Was it Alabama when they had
It was partly
weather?
or
Somewhere.
a TVA plant. Yeah, one of the TVA plants, I think. But they had brought people. I don't know. Anyway, this plant had brought people on site to quarter them in preparation for this bad weather, and they had to go through this little drill of redefining or coming up with an exception for this definition, for this regulation. And all of that, of course, is approved by the regulator ahead of time, and it's all documented. It's all cool. Unrestricted area, on the other hand, is an area that is neither limited nor controlled by the licensee. It's totally outside of their control. Unrestricted means just that. And then the last general definition is waste. And this actually becomes important to us, I think it's in our next lecture series, when we start talking about radioactive waste, because this is the definition that we'll hang on as far as the starting point. But it's those low-level radioactive waste that may contain, and you'll notice it can contain any of the three types: source, special nuclear, or byproduct material. And the waste has to be in a form that is acceptable for disposal in a land disposal facility. And as I said, we will talk about that waste in detail in our next lecture series. Now I've got this little diagram, go back and kind of take some of those things we've discussed and put them in perspective for you. The restricted area would be the most inner portion of your site. It's the area that is controlled for purposes of protecting personnel from radioactive material and radiation. The controlled area would be the area around that access may be controlled. And then beyond that would be the unrestricted area. Unrestricted area basically would go out to, it actually goes all the way out, but you have this other little thing called site boundary, and that really comes into play for emergency planning purposes. But the site boundary is basically the property line for the utility. It's the land that they own. So that kind of hopefully clears up those definitions a little bit, puts them in
Is there
perspective.
site boundary be like at this area, how the gates run around this area, or would it be the whole plant area?
Around where?
Like, when I worked in this area, you have to check in through a gate. Even after you get on the plant, you have to check in through the gate of this area. And it's completely gated all the way around this area.
Would that not be considered?
Would that be
control
considered your
area?
site boundary? Or
I'm not familiar with this.
Okay.
What is it? What
It's
is
going to have a
it?
reactor over there.
Oh, it's one of the reactors? Okay. Out there is a little different because you had more than one reactor. You had, the site boundary is what SRS owns.
Okay.
That's the Banner River site. Then you have within there these little pockets where the reactors were. You had the restricted area, which would have been the probably that fenced area. To get in there, you had to have a TOD.
Yep. You had to have that in the bag.
So that would have been the restricted area. And then moving out, the controlled area, I would think, and you start crossing lines here, because sometimes you control access for security reasons, and sometimes you control access for radiation. And I'm not sure how they were set up out there totally, but that fence that you crossed into to get at the power block, that was probably the restricted area. Other questions? All right. Let me get these general definitions for 835 out of the way, and then that's where we'll end our discussion tonight. There's just a couple, three of them. NCFR 835. Now, you do need to understand the two different sets of regulations. One does not apply to the other as far as the license is concerned. So if you're out at SRS, all those definitions we talked about with 10 CFR 20, none of them really apply unless they're duplicated in 10 CFR 835. You do understand that, right? Two different entities. Control area, basically the same definition, just a little different. Means any area to access is managed by or for the DOE to protect individuals from exposure to radiation and radioactive material. Really just injected the radiation and radioactive material as well as the DOE. The control area out there, as this says, is for the purpose of protecting against radiation and radioactive material. Whereas 10 CFR 20, that was the restricted area. Entrance or access point, and I think this is almost word for word. Pretty much the same. And then radioactive material area. It's interesting, 10 CFR 20 does not have a definition for radioactive material area. It does talk about when you have to put posting up, which in effect defines a radioactive material area. But if you go to the definitions section, it's not in 10 CFR 20, but it is in 10 CFR 835. So it's any area within a controlled area, accessible to individuals, in which items or containers of radioactive material exist, and, important word, and the total activity of radioactive material exceeds the values that are in Appendix E. And if you go to Appendix E, you'll see it's a list of all kinds of isotopes, starting with tritium, and it goes on and on and on and on and on and on and on. What I want to point out to you is that this also tells you that this is the definition for when you have to post an area as radioactive materials area. It also tells you what to do if you have a combination of isotopes, which is probably going to be the case in a lot of circumstances. And what you do is you take the is provided here, right here in the note. Can't read that up there. I'll read it to you. It says, when there is involved a mixture in known amounts, derive the value for the mixture as follows. You determine each radionuclide in the mixture, so which radioisotopes are you dealing with. You take the ratio between the quantity present in the mixture and the value otherwise established for the specific isotope. And then you add all of the fractions together. If the sum has to be less than 1. So what you do is you take how much of the isotope is present, take how much of the isotope is present, so the concentration, divided by the table E value, and you do that for each isotope. Et cetera, et cetera, et cetera, et cetera. And the total of that's got to be less than 1. If it's greater than 1, then it meets the requirements for posting and controlling as a radioactive materials area. Everybody get that? You might also notice that there's a note that says right here, any alpha emitting radioisotope not listed in Appendix E and mixtures of alpha emitters unknown composition will have a value of, and it gives you a value of 10 microcures. So if it's not in the table, or you have an unknown mixture, I'm sorry, I should have said it's not up there. There. So if it's not in the table, or you have mixtures of unknown quantity, then you have an arbitrary number of 10 microcurids limited. So if it's more than 10 microcurids of whatever it is, then it's got to be posted and controlled as radioactive materials area. Any questions on that? Okay, close that out. Now they, NCFR 835, see the need to define this. It's called radioactive material transportation. And the reason I think it's there and it's not in NCFR 20 is because the DOE facilities are so large, and while it's an owner-controlled area and it has its own little highway systems and such, and there actually may be times when you're moving from one part of that complex to another part of the complex, you're not going over public highways, but you're still transporting it. And so they give this definition. It means the movement of radioactive material by aircraft, rail, vessel, or highway vehicle. And I think we actually looked at one of the regs that uses that term, and it kind of gives the impression that it is within the facility when we're using that term. And you'll see it does not include preparation of material or packages for transportation, storage of material waiting for transportation, or the application of markings and labels required for transportation. It's just the actual physical movement. And the last one is source leak test. When we get into talking about sealed sources, we'll talk about this leak test. But this is really, that's exactly what it is. It's a test of a sealed source to determine if it's leaking. A sealed source is usually a capsule, usually a metal capsule. But you could actually, you know, those little sources we use, you could consider that a sealed source by that definition, because the source material is contained within that epoxy matrix. We're not required to do a leak test on ours because it's not high enough quantity. But to do a leak test on it would be to do some type of assay on the outside of that disc, and then count it to see if I pick up anything. And if I pick up something, that means it's leaking. And that's all that is. It's a source leak test to determine if the radioactive source is leaking radioactive material. So we will stop there. When we come back next week, we're going to pick up categories of radioactive material. I will have the test graded by then, and we'll review that. Other than that, any questions? Thank you for hanging around. Happy birthday, Chad.
Email clerk what your topics going to be on this week. Email clerk what your topics going to be on this week.
What else though? No, there wasn't.
Standards for protections, radiation versus standards for protection.
We did it, like, you already supposed to do your weekly thing.
No, I do not.
We gotta get that together. We got 1 week. 1 week.
Okay, so, I mean, I read the email, but, so what exactly were you doing with it? I heard something about 5 cars splitting it up.
Yeah, well, we did the, I think everybody's completed the, list of, problems or whatever, like.
One person has to complete that, everybody has to complete that.
I know, but we just split it up, like I answered 2 problems, Jerry answered 2 problems, and so forth, because there's only like 10 problems altogether. But we got like, for the presentation, I'm not good at creating PowerPoints, so we're gonna figure that out. I don't mind doing the talking session.